so we got our next topic, which is the division of line segment. Okay, so we have a just zoom it first. The division of line segment is this one. So we got a example here, or the principle. So let's say that this is P2, P1, and then P0. Okay, so we got coordinates x2, y2, x1, y1, and x0, y0, or xo or yo. So as you can see, so this part will, so one, this one will be y2, right? So this will be y2, that will be y2, and then this whole will be y2, right? And then this one will be yo, okay, yo. So to get this part, that will be just y2 minus yo, okay? And that also applies with the x. As you can see, this whole one is x2, right? So this is x2, and then so this is x2, and then from here to here, this is xo. So to get this one, so this will become x2 minus xo, and so on and so forth. So if you were able to get this one and provide the proper length of every line here, you'll end up with something like this. And then all you have to do is just relate each other using similar triangles. So using this triangle, okay, let me just change the color for you guys to see it better. So this one, a good one. How about this one, blue one? Okay. So this one, this triangle, and the bigger triangle. Okay. So if you will relate those two using similar triangles, you'll end up with something like this. So how did we arrive into this one? So that is the height of this one, the height of this one is yo minus y1, right? And then the height of the bigger triangle is y2 minus y1. That's why it's the same with this one. So yo minus y1 all over y2 minus y1. So that will be the same with the x. So this one is xo minus x1, this is xo minus x1, and then the large triangle is x2 minus x2, x2 minus x2. And then as you can see, that's from point here to here, right? Kaya that is why P1 to PO, P1 to PO, and then from here to here, that will become P1 to P. That is just equal to. Okay. So if you will arrange this one, so you'll have here this one equal to r. So you'll end up with this, like something like this, and then rearranging that to isolate xo. So xo will become like this. So same thing with the y. So this one equal to r. So here you go. And then next one, isolate yo. So isolating yo, you'll have something like this. So if it is 3D, you'll have a z value, or the third chord. And then we have a special case. So the special case is midpoint. So this is very easy. All you have to do is just add the coordinates and then divide it by 2. That's why x2 plus x1 divide 2 to get the midpoint, and then for y, so y2 plus y1 divide 2. If it's 3D, of course, you will have a z coordinate. So z2 plus z1 all over 2. That's it. Okay. Okay. So let's try to answer this one. So let's try answering number 1. So for number 1, find the coordinates of the first point that trisect. So trisect the line segment from 3, 2 and negative 2, 6 from point 3, 2. So let's try to draw a Cartesian plane. Okay, so let's try to draw a Cartesian plane. Okay, and then we have to plot -2 and -6. So let's say that this is -2, and then let's say 1, 2, 3, 4, 5, 6. Let's say that this is the point. So this is -2 and -6. And then we have another one which is 3 and 2, right? 3 and 2. So 1, 2, 3, and then 1. Let's say it is somewhere here. So this point will be 3 and 2, right? Okay. And then we have to connect these two. So connecting those, you'll have something like this. Okay. So this will now be the point. And then you have to find the trisect. Therefore, we have to divide this into three portions. So dividing that, you'll have, let's say this is the first one, and then this is the second one. So let's say if this is D, of course, those three are equal. So D, and then this will also be D, and then D. So you have to find the first point from the point 32. So if this is point 32, therefore this is the one that we are looking for. So let's say this point is, and then so this point is that is x0, y0, xo or yo. Okay, so since this is we are looking for the trisect point, first point that trisect the line segment. So starting from 3, 2, let's say that this is your P1, and then this is your P2, okay? And then this will be your P0. Okay. So what will happen is, since we have, therefore, let's put down all the givens. So x1, we have y1, and then x2, and then y2. x1 will be equal to 3, and then x2 is 2, and then y1 is 2, and then no, x2 will be -2, right? -2, and then y2 is -6. Okay, all you have to do is just apply this formula to get the values. Okay, but since we are looking for here to here, right? Therefore, that will become P1, okay, P1 to PO over the whole line. So P1 over PO, the whole line, which is P1, right? P1 to P2. And this will be your R. Okay? So P1 to P2, that is that. P1 to PO, that's D, right? That's 1D over P1 to P2, which is 3D. Okay? 3D. So this will be equal to 1/3 because you can just cancel out D. Therefore, this will be your R. Okay, so let's solve XO. All you have to do is just follow this formula, this one. So following that formula, you'll have XO is equal to R, which is 1/3, times X2 is -2, minus x1, 3, plus x1. x1 is 3 again. Okay. So this is equal to 4/3. And then y0 is equal to, or yo, this will become 1/3 again, times y2 minus y1, so negative 6 minus 2 plus 2. Is that right? And this will be equal to negative 2/3. Therefore, um, PO, or the first trisection point, will just become 4/3 and negative 2/3. Therefore, this will be your answer. Okay. So let's move on to number 2. Number 2 is quite easy. So for number 2, find the midpoint, right? So we have, again, x1 and y1, which is 3 and 2, and then x2, y2, which is negative 2 and negative 2. So to find the midpoint of x, just add those two and then 1/2 divided by 2. So 3 minus 2, so this is equal to 1, and then that will become. And then to find the midpoint for y, that will become 1/2, and then 2 minus 6. So that is negative 4 divided by 2, negative. Therefore, the midpoint, or let's say that is PM, midpoint is just 1/2 times negative. And this will be the answer. So let's move on to the next topic.